Saxon Advanced Mathematics, Lesson 52. We are back to talking about trig equations, and we're going to add a new little wrinkle to it that's kind of fun. So let's dive in. Example 52.1. There's a little bit of vocabulary to this lesson too. I will introduce it to you once we get in. All right, solve is our instruction. The tangent of 3 times theta okay. Here's our limiting explanation. We're happy to see that. And we look at this and we go, okay, let's add the 1 to both sides, right? We want to use algebra to simplify this. Tangent of 3 theta equals 1. Now, before we've had numbers out here and we've divided to make them go away. Can we divide this by 3 to make that number go away? No. We can't divide by 3. And the reason for that is what's called the inviolable argument. And that is the ARGU. That is the terminology I wanted to introduce today. The argument is this, okay? It's the part of the description that comes after the trig function, right? This is called the argument. We can't tinker with that. We have to leave it alone. We cannot mess with that because we can't mess with that 3 because that is part of the argument. It's not over here in the front like those other problems were when we divided it away. This 3 is part of the argument. We cannot violate it. It has to be protected at all costs. So we're going to have to find another way to deal with that 3, and I will show you in just a minute. All right? So let's just kind of ignore the fact right now that that's a 3 times theta. And let's just say, okay, how would we find a tangent of 1? We can make it 1 over 1. We know that tangent is equal to over Arthur, right? So is there a triangle we know of where the opposite and the adjacent are either both 1s or are the same? Aha, yes we do. Because that's what a 45-45-90 is all about, right? So let's take a look at this. We know there's 4 quadrants. We know that we only have to deal with 4. We know that 2 are going to be positive, 2 are going to be negative. Here's my page. Tangent is positive in the first and third. Okay, so let's draw those in. I'll start with this one. It's a 45 degree. It's 1 square root of 2. Tangent is opposite over adjacent. So that works, right? So we know that that is one answer. But we are going to be careful when we write our answer. We're going to write 3 times theta equals 45 degrees. Right? And then we also know it's going to work down here. Because tangent is positive in first and third. Let me just look at that. Yeah, first and third. Okay, 1 square root of 2. This then is the other solution. 3 theta equals, let's see, it's 180 plus another 45, so that's 225, right? But we're supposed to solve for theta, not for 3 theta, right? So what we have to do now is divide each of these by 3. Theta is equal to 15 degrees, or over here, this divided by 3 is what, 75, right? Yes. Okay. Now, here's where it's tricky. We said that theta is limited to just those values. not 3 theta, but actually theta. So that means we're going to have to take into consideration some extra spins. Let me get another color pen so I can tell you what I'm talking about. Let's look at just this triangle right now. A 45-degree triangle leads us to a theta value of 15, but our theta values can be higher. So what happens if we start here and we go around the circle again? That would be adding 360 to this. So that would give us another value for 3 theta of 405, right? But when we divide that by 3, that would give us a value of, what would it be, 135, right? Yes. That's still within our range, right? 3 theta is out of the range, but our actual value of theta is within the range. So we have to include this second value, and I'll tell you how I know in just a minute, but we have to do it a third time. Okay, so let's go around one more time. That will be, I'm going to write it up above, 360 plus this, it will be what, 765 degrees. But when we divide that by 3, it's 225. So our values for theta in the first quadrant are all of those. Okay? Because those are the ones that fall within there. We're not judging it based on the 3 theta. We're judging it based on the actual theta. Okay? And I'm going to globalize a rule out of this when we're done. Now let's do the same thing with this triangle, and I'll just make the circles bigger. We've got 225, right? That was our first one. Now we're going to go around a second time. That means we add 360 to this, and that would be what, 585? Yes. Checking my math over on the book. We divide that by 3, and we find out that we have a second theta value of 195. And then we go around one more time, just like we did it with the other triangle. That's another 360. So that would be 945. Divide this by 3, and it's 315. So our values for theta require extra spins, not because this was wrong, it's this guy's fault, okay? That coefficient in the argument requires extra spins, if that makes sense to you. Okay, that's how my brain thinks of it in non-mathematical terms. The coefficient requires us to do extra spins because we're dividing those numbers down to get the actual values for theta. Okay, this number in, no, I don't want to write it there. The coefficient in the argument minus 1 equals the number of extra spins. Okay, this is good to know. You could get that answer the hard way, but I'm going to explain what I meant for that. Our argument has a coefficient of 3. According to this formula, that means we needed 2 extra spins, and that's exactly what we did, right? We had our original calculations in the green, then I spun 1 extra time in blue, and then a second extra time in orange. That is why I knew I only needed to do 2 extra spins, is because of that coefficient. If this coefficient was, say, a 5, then I know, okay, set up my original triangles, then I have to do 5 minus 1, 4 more spins, okay? So this helps you know how many additional spins you need because this coefficient is requiring us to do extra work. We cannot get rid of that coefficient because it is part of the inviolable argument, so we just have to deal with it. And we remember that this limitation is based on theta, not on the coefficient times theta. I hope that makes sense. Even if you don't understand the why, I hope you can understand the calculation. We're going to do one more in just a minute, so don't worry. But the way we write these answers is John usually writes them in order. So what he does is he mixes back and forth. He would say theta equals 15 degrees, 75 degrees, 135 degrees, 195 degrees, 225 degrees, 315 degrees. See, he's putting them in order. Rather, I've got the 3 for one triangle and the 3 for the other triangle. I don't care how you write it. If you want to write them like this, actually, I think that's really nice because I would be able to follow your work really clearly. If you want to write them one more time and put them all in order, beautiful, I love it. That is just fabulous, okay? Let's look at one more wrinkle on this. The same rules apply, but we're going to do it just a little bit differently. Example 52.2. This is the last example. I have to say, you guys, these 4 lessons we did this week, I'm really happy about how to the point they are. Not a lot of drama. Okay, solve. Cosine of theta over 2 plus square root of 3 over 2 equals 0. And then we have our usual limitation. But we're careful about this now because we see, oh, here again, we have another inviolable argument. We're going to have to be careful. Now, this one's a fraction. It's not being multiplied. The one when we multiplied, last time we did 3 and we had to do 2 extra spins. So I wonder what the fraction will do. Let's find out. Okay, the first thing we're going to do is rearrange. We're going to subtract the square root of 3 over 2 from both sides. And I'm going to get the cosine of theta over 2 equals minus square root of 3 over 2. Cosine is a hold. So I want a triangle where the adjacent side is the square root of 3 and the hypotenuse, sorry, I was drifting off. The hypotenuse is 2. So that means, let's draw our pictures. We know there's going to be 2 quadrants. It's negative. Let's look. Cosine is negative where? Cosine is negative in second and third, okay? And so we know we want, let's take a look at our triangle. This is 30, this is 60. We just have to figure out which way we want our triangle oriented. This is 2, this is 1, this is square root of 3. We want square root of 3 to be the adjacent and 2 to be the hypotenuse. Adjacent is here. Okay, so this is how we want it, right? Because this will be 1, 2, square root of 3. And then this is 30 degrees. And then we'll want the same triangle right down there, right? There's the angles the way we want them. Okay, so we want theta over 2 to be equal to That would be what, 150 degrees, right? Because it's 30 short of 180. And then we want the second one to be 210. Okay, so we're being very careful to remember that this, what we're calculating here, is still theta over 2. So theta over 2 can equal 150 or 210. Those are the two triangles we found. That means we have to, in order to simplify these to just get theta, we have to multiply these by 2. 300 degrees. And this one says theta equals 420. So when there's a fraction, we have fewer, right? Because this is too big. So even though theta divided by 2 was perfectly within our range, once we adjust it to just get theta, we have fewer solutions. This is the only answer to our problem, okay? So when we're dividing, we have one fewer when divided by 2. When the argument. Okay, that's what happened in this case. I'm not going to globalize that into a rule like I did for you here, where I told you that you can always subtract 1 from the coefficient like this to know how many extra spins you'll need. This one, you can globalize your own rule to figure out, okay, how does this relate? Is it always 1 fewer? Is it 1 less than that? What if this was a 3 here? How does that work? So you can figure out that rule, but you can see how it works, that when we're dividing by a coefficient, we're actually going to have fewer solutions because our answers get big. Okay, that is the end of lesson 52. That's the end of our first week back. I hope math in 2021 is being kind to you. I love that you have a fresh start to catch up. Please do your homework wisely. Use the solution manual sparingly. Do all the good stuff that you know how to do. Even answers only. Be careful about checking a whole lot. Like at this point in the week, now that we're done with 52, I hope you're not using the solutions manual for lesson 49 and maybe 50 at this point. So be careful with that. Fabulous. Yay. Lesson 52. I will see you next time.